Welcome to Chemistry 1B's example 5. This is with coffee cup calorimetry, a very similar example to the one that you will do in the lab as one of your experiments. So in this instance, sodium hydroxide and hydrochloric acid undergo a rapid exothermic reaction when we mix equal volumes of equal concentrations of hydrochloric acid and sodium hydroxide. The initial temperature of the coffee cup calorimeter is 25.5 degrees and the final temperature is 32.2 degrees. You are asked to calculate the enthalpy in kilojoules per mole in terms of the hydrochloric acid only. Then there's a few things given to you that you're to assume that the specific heat capacity of the solution is the same as that of water. So here is your specific heat capacity of water. It's the same as the solution, and then you're given some density values that the 1 molar HCl density is 1.02 grams per mole and the 1 molar sodium hydroxide is 1.04 grams per mole. The equation for the reaction is given there. It's a 1-to-1 mole ratio, as you can see. We have 1 mole of sodium hydroxide reacting with 1 mole of hydrochloric acid, and we can then proceed to work out the heat absorbed by the solution, knowing that we have the mass times the specific heat times the temperature change. In order to work out the mass of each solution, we take the volume and multiply by the density, because we know that mass is equal to density times volume. Okay, so then we have the masses. We then can find the total mass of the solution by adding the two together, because remember, when we add them together, their volumes and their masses are therefore additive. And so we have a total of 103 grams of solution. And finally, we can work out the temperature change, which is found to be 6.7 degrees C. Continuing on, we can work out the heat absorbed by the calorimeter by taking the mass multiplied by the specific heat multiplied by the temperature change, and we get a value of 2,890 joules, which we can round to 2.9 times 10 to the power 3 joules, or 2.9 kilojoules. Okay, so therefore the heat of the reaction is then the heat released by the reaction, so therefore we have to change the sign. So the heat is now minus 2.9 kilojoules. Okay, and we know that we have 50 milliliters of your hydrochloric acid solution, which translates to 0.0500 liters. Okay, and that gives us the number of moles of hydrochloric acid that we have, because we need to determine the number of moles, because ultimately we've been asked to calculate the heat evolved per mole of hydrochloric acid. Okay, so we need the number of moles. So this essentially then becomes an equation where we have delta H is equal to Q over N, the number of moles. It's another equation that you can add to your arsenal of equations. And if we work out this value, we see that the heat of reaction is minus 58 kilojoules per mole.